guys? So we're now going to apply our knowledge, what we've been doing, okay? So the above table gives selected values for a polynomial. The function is smooth and continuous over all real numbers, assuming all zeros are given. Use the table to answer the questions below. All right, so we have this, and we're going to practice plotting and looking at the scatter plot. Is that okay? We're going to recall doing how to do that in our handy dandy calculator. Is that cool? All right. Do we remember how to do it in our handy dandy calculator? How do I create a scatter plot? Bringing back those skills. Where do I go? Where do I start? I got to go where first? I need to put it in first, guys. Stat edit is where we start. We start in stat edit. Do we remember? Bringing back some memories a little bit, hopefully. All right. I'm going to reset Sylvie here. Second plus 712. I'm going to input my table. So stat edit is where I'm inputting the table. Yes? All right. So I'm going to put in 0, 2, 4, 6, 8. Okay. And then I'm going to put in my values. So I have -40. We have 0. We have 8. 0. Hopefully y'all understand why I emphasize this so much in Algebra 2. Okay. After I have this, to create the scatter plot, we are going to go to y equals, and we're going to turn on the plot. Do y'all remember that? To turn on the plot, you just press enter. And then we're going to go to zoom, and we want to go to zoom stat to tell it to plot our graph. Did it plot our graph for us? So looking at our graph, what do we have? What are our points doing? I'll do it again. All right. So let me do a thumb check. Are we all good here? Can I get thumbs up? Stat edit. Second plus 712. Thumb check on this. Yes? Then we went to stat edit, put in our values. After stat edit, we're going to go to y equals, and we're going to turn on our plot 1. Notice how mine is bold? That's because you go up and you press enter to bold it. And now our plot is turned on. So we're telling the calculator, I want you to put these on a graph for me. Make sense? Then I tell the calculator, I want you to plot it for me in a specific view. So you're going to go to zoom, and you're going to go to zoom stat. And then it'll plot it in the window so you can see your points. So looking at this graph, my points are doing, on the left side, I am going down, and on the right side, I'm going up. So that means that, what type of function is this? It's an odd what? An odd positive. Because I end positively on the right, that makes me positive. And because I'm doing opposite in behavior, that makes me odd. Make sense? So I'm an odd positive. Yeah? Okay? So from there, I can identify what I'm working with. So we know that we have essentially something like this, correct? So this is an odd positive model. Okay? From our sketch plot, can we identify? We know that because it's odd positive, we do not have a what? We do not have an absolute max or min, but we do know that there is going to be a local or relative, correct? So there's going to be a local or relative max and a min, correct? So looking at our sketch, can I predict? Okay, so my max takes place between where? I don't know exactly, but it takes place between, what's the first value? Is that 2? And 6. So I have a local max. Oh, I wrote it in the wrong spot. That's for my min. Dig. Local on. We're going to do part B first. a local max between x equals 2 and x equals 6. And how do I know that? That's because that's where, if we're talking about it, that's where my y values are increasing, and then they're going to do what? So I increase and then I decrease. Does that help? Is that 0? Oh, it's right here. I see it now. It's all the way down here. This one goes here. I don't think we did that right, guy. This is a bad window. Window. I don't like it. Y scale. I'm going to switch this to 10. I'm going to keep you at negative, and you can come down to 20. And everything else should be fine. And you can count by 2. So let's see if this makes it prettier. There we go. Whew. All those lines were just not working for me. All right, so let's look into where we're going. So we are increasing, negative 40. So from negative 40, we go up here to 0, correct? And then from 0, we keep going and we're at 8. And then we come back down and we go. And then, yes. So between here and here, we have a maximum. Why is it a maximum? Because what are our values doing? We increase and then they decrease. How else am I going to make a mountain, right? So the value, the y values increase, then decrease from 2 to 6. Yes.
You have to say it's whatever, or can you say the exact point, like at 40?
I don't think you don't know that's at the exact point. Yeah, but that's not the exact point where that maximum takes place. Yeah, so that's why you have to say it's an interval of where it's changing. Okay, where does my minimum take place? So we're saying somewhere between, what is this value? 4 and 8. So there's a local minimum between, that got really weird right there, x equals 4 and x equals 8. Why is that? What will be our reason? What are the values doing? What are your y values doing? Our y values are, there you go. The y values increase. Then I wrote that backwards. Oh man, I hate erasing. Decrease. Good. They decrease, then increase. From 4 to 8. Now, this is like the shortest way of explaining why. There's as long as you understand that and see that, I'm good with it. What I wanted to show you is that what it would really look like and why we have to give an interval. If I was to actually run the cubic, so actually create a cubic function, I'm going to run the cubic. I'm going to store it so it'll graph it for me so we can see the connection. So I'm going to calculate and it says, okay, here is your cubic model. When I go to graph, it'll draw the cubic function in there. So this is just an approximation, but notice that this would not necessarily be the exact. Does that make sense? It is not my absolute, well, my local maximum. It's not my local minimum. So that's why we have to give it a range of where it lies. Does that make sense? Okay, because it wasn't pinpoint at this point. And we don't assume unless it says you have a local maximum at blah, 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 blah. All right? Okay? Got it? I thought we were. I was ambitious.